All right, hey everyone. Today we're going to do portfolio optimization with two assets and two states. All right, so we've got GeoGebra up here, so I'm going to go ahead and start calculator. Um, we're going to do this in 3D, but you actually can do it in 2D, but I'm going to do it in 3, and I can show you how to do it in 2D, but we'll start with 3. Okay, so we're doing two assets, two states. So let's go ahead and make ourselves some assets. So the first one is going to be just cash under your pillow, right? And so that's $1 in the bad state, $1 in the good state, and negative $1 of cash flow today. And then the stock in the bad state would give us 0.9, and then good state would be 1.2, and the cash flow is negative 1 today. Okay? So here we go. We've got ourselves, we're already cooking. So let's go ahead and make ourselves a plane through these points. 1, 2, 3. All right, I've got a plane. And the next thing we're gonna need for this, and remember we're doing portfolio optimization, okay? So the first thing we'll do is to do the portfolio optimization, we need a utility function to optimize over, right? So let's go ahead and make ourselves a utility function. So I'm going to come over here. So in this portfolio optimization problem, a lot of times people, sometimes you could have like utility. That's pretty thick. Let's do, how do I undo? A lot of times we'll do, utility. My goodness. Okay, so one would think that you might have utility at time 0, and then something with like utility at time 1, and maybe you'd sum these or something like that. But in portfolio optimization problems, what we're going to do is we're just going to forget this one. We're not going to do anything with that. So all we're going to focus on is the utility at time 1. Okay. So how do we find the utility at time 1? It's an expected utility, right? Because we have two states that we don't know which one is going to happen for sure. So the typical way of doing that, we say the utility is going to be equal to the probability in each state times the utility in that state. So let's assume that we're at 0.5 in each of these. So utility in the down state plus 0.5 times utility in the up state. Right, so this is just saying, okay, we're taking the average of the two utilities, so the utility in the down, utility in the up. And we can use a couple different utility functions, but actually the one I'm going to use here, I kind of like it. So let's say A is constant. So this is going to be sort of our lever. This is going to be like our curvature, right? So if we have a utility function here, something that looks like this is not that curved, so this is not very risk averse. And here, this one's more curvy, so this one is more risk averse. So we're going to use A to determine our curviness, okay? So how do we want to do this? So A is our constant. Okay, so the utility function we're going to do is negative A to the negative X. That's going to be our utility for any of these states. Okay, so what I'm going to do is I'm going to undo that just real quick, and then I'll do 0.5 times, what was it? It was negative A to the negative X, right? And this X is going to be the payoff in state 1. So P in state 1, and then plus 0.5 times negative A to the negative payoff in state 2, right? Okay, and since this is a utility function, scaling doesn't matter. So let's go ahead and let's pull out this 0.5, right? In particular, positive monotonic scaling doesn't matter. So let's just also do negative A to the negative P1 minus A to the P2. Okay, so this right here is the utility function we're going to use. And our A is just sort of this free parameter that we can use to tinker with how curvy it is, okay? All right, so there's going to, let's just go ahead and plot this, okay? And then in our case, so P1, maybe if P1 is the downstate, that's going to be, for us, that's going to be the X value, and this is going to be the Y value. So we'll also do negative A to the negative X minus A to the negative Y, okay? So let's go ahead and do that. So let's give ourselves some A variable. I'm just going to leave it there for now. And then we'll say, so negative A to the negative X minus A to the negative Y, okay? All right, so now we have ourselves a utility function. And I'm going to move this up a little bit. Okay, so let's make this minimum of 1. All right, so this is under the plane there, but you can see here that the utility is going up as you, and whoops, I did not mean to do that. Let's see if I can undo that. Oh, nope, I can't undo it. What did I have there? A should just be 1, 1, 1, 1. Okay, so what's happening is, you know, as you get more payoff in the down state, you know, of course, this is going upward, so your utility is going up. And then if you get more payoff in the good state, sure enough, your utility is going up as well, okay? And it's curved downwards, which means this person is risk averse. And as we said before, as we crank A up, right, it gets more curvy, which means more risk averse. And if we make it less, then it's less and less risk averse, which means they're okay with risks. They're more neutral on risk over here. This is very risk averse, okay? So we'll just leave it somewhere over here for now. That's fine, okay? So now the next thing we want to do is we want to make ourselves a constraint, okay? So let's say we have $0 to start with. Actually, that's maybe a little too abstract. So let's make ourselves a little vector here. First of all, let's say the initial amount of wealth we have, let's call it W. Does that work for us? Okay. Yeah, so the initial amount of wealth we have is W, right? So I'm just going to make a vector, and it's going to be 0, 0, and then the wealth. Okay, so you can see here I just made a little vector that's 1 high, okay? So now what I'm going to do is I'm going to shift this whole plane up by that vector. Let's see if I can just do P plus U. Does that work? No, I didn't like that. Okay, so what am I going to do now? I'm going to shift I'm going to shift these points, right, to by this vector, okay? So I'm going to do A plus U, and then I'm going to do B plus U, and then I'm going to do 0, 0, 0 plus U, okay? And now I'm going to make a new plane through those. Okay, what was it? It was DEF, so plane DEF. Okay, we got ourselves a new plane. I'm going to go ahead and hide this plane. Okay, I'm going to hide the first one. So now we have our new plane, right? So if we have $1 at the beginning, and I can just go ahead and change our initial wealth, right? Our initial wealth is 1. So if we give ourselves more initial wealth, that's how we change this plane, right? Okay, so let's say our initial wealth is, let's put it at 2. Okay? So we have $2 to spend. And if we have $2 here, and based on these two assets down here, we can get anywhere on this plane, right? So now what we're trying to do in this portfolio optimization problem is we say, okay, we're going to invest these $2 so we can get anywhere on this line where our plane intersects this with the XY plane, right? So I'm going to intersect two surfaces. I'm going to intersect this plane up here and the XY surface, right? So now we have this plane right here, right? And so what we want to know is, all right, if this is what's achievable for us, now where should we go on this? If this line is the achievable stuff, in fact, the whole plane is achievable to us. But again, this is an investment problem. It's a portfolio optimization problem. So all we're saying is, okay, we have $2. We're just going to invest all of it. So that's why I'm intersecting the plane with the XY plane, is because we're going to invest all of it. So assuming that these are the only reasonable places we would want to be is on this line here. Okay? So now the question is, okay, well, which point on this line do we want to be on? Which point here gives us our maximum utility, right? And you can maybe ballpark it just kind of by looking around here. But the real way to do it is to draw some level curves of this, right? And there's a couple ways to do it. You know what? Let's just try this. Okay, let's try this. Let's do z. Let's just make ourselves a plane. Let's say z is equal to, let's give ourselves a constant. What's a constant we haven't used yet? Have we used the constant p? Yeah, we have p there. What about, we use w. What about lowercase b is here. What about n? N? Okay, n is a good number. Okay, let's do z is equal to n. Okay, so now if I move this around, right, you can see I'm just cutting this flat plane, right? Okay, so now what we'll do is let's intersect this plane with our utility, okay? So now if I rotate back, looky there, okay? So now what are we doing? So this surface, or this line here, this curve here, that is our kind of the cross, like it's the slice through our utility function at a utility of negative 1.4. So now, if we go here on our feasible portfolios, we're going to have negative 1.4 utility right here or here. And now the question is, oh, well, can we get somewhere on our little line that's higher than negative 1.4? Well, sure enough, if we make this a little higher, right? And as I'm cranking that up, you can look at it from this angle as well. That's getting higher, right? Okay. So now I'm going to come back. I'm going to rotate us back. All right, we went a little too high, right? So where do we want to be? We want to be about right here. Okay. And if we want to, we can make this a little more granular as well. Well, the wealth is not what I want. I want n, right? So where are you, n? Okay. Let's do a 0, and then here we'll do about 2 or something, and then, oh, is that where it was? Where was it? Did I do something wrong? Alright, so yeah, I set this minimum to be 0, but I shouldn't have. It should be a little bit lower because our utility function, our utility surface is actually negative in most places. So I put a bad bound on here. So negative 1 is actually a little bit, yeah, that's about where we want to be, right? Okie doke. Yeah, sorry about that little confusion there. Okay, so if I come here, all right, so now n is more in the range. I can go into settings here, and this slider I can have it increment by, like, what do we want to do, 0.02 or something, so we can maybe hopefully get a little closer to exact. Let's see if we can get something a little smoother. Yeah, looky there. That looks like a good spot. Okay, so now what's that saying? So if we come here on our portfolio, if this is the asset we choose, or if this is the payoff we choose, then that is our optimal scenario, right? Okay, so that's what we've done, and there's a couple more parts, and we'll pick up right here where we left off in the next video.